Okay, guys. Thanks everyone for turning up and coming to listen about cars, something a little bit different, but hopefully by the end of this talk you realize that it's not as different as the mobile world that many of you may think it is. So some of you may have seen that there was a talk given last week at DroidCon Berlin by my colleagues. That one dug into design far more than this one will. This talk is more technically focused. If this whets your appetite and you want to learn more about design, then feel free to go and visit that talk as well, and you'll be able to view a YouTube video of it soon. But if you've seen that already, this is not just going to be a duplicate. This is going to be some new content for you. So some of you may be familiar with this wonderful car. This is the Mini. This was in production for the best part of 40 years, and cars have that kind of lifespan. They also have horrendously long development spans. So the large motor manufacturers now are looking at developing cars for release in 2023, 2025. They're not looking at the same kind of timescales we do with apps. They're not looking at this year. They're not looking at getting stuff out even next year. The hardware level choices are done many years in advance. A great example of that is the Polestar. The Polestar 2 is a car that was released last year. It runs Android Automotive OS, which is fantastic. It runs it on Intel hardware. Now, put your hands up here if you've seen an Intel-based device in a shop in the last 2 or 3 years. Yeah. I'm in the same boat. The Intel hardware choice was made long before Intel decided Android probably wasn't a thing for them. So these development leads mean that what you'll see appearing in cars is hardware that may be 2, 3, 4 years old. So when you're developing for a car, if you're testing it today on a Pixel 6 Pro and it's okay performance, you're going to need to do some heavy reworking. The hardware decisions are so old by the time the car is launched. Your average Pixel phone has gone from launch to deprecation in that time span. And in the example of cars launching today, like the Kia EV6, that's the Pixel 3. The Pixel 3 was launched in 2018. This is its last month of security support. During that time, you will probably find that the hardware that's in the EV6 from Kia has existed, but is now rarely used. So there is this wonderful thing as well, cockpits, cockpit design. Some manufacturers go absolutely over the top. You're not going to be able to control every screen here, but this range of screens gives you an idea of the different types of screen ratios you've got to deal with. There are multiple screens in the car. Some have to be dedicated to safety functionality. Some have to be telling you how fast you're going, your revs, your fuel. There are legal requirements for these kind of things, and you're unlikely to influence those. Some, like the one on the far right, that may well be playing as a movie or may just be showing you a camera of what's going on. There are multiple ideas for that. Amazon are one company who are making inroads into that, and the other area, which is called rear seat entertainment. They've basically taken an LCD panel, put a Fire TV stick on the back of it, and that's what's in the car. There are other car manufacturers who are putting aquariums into their car as something for the passenger to watch while they drive. Those are the kind of screens that you can look at interacting with. Then you come to the middle area where you've got the more driver-sensitive information, like you can have navigation, you can have car status, you can have reversing cameras and all that kind of thing. You can also write apps for that area, but they tend to be more restrictive. You have to think about driver safety. You have to talk about distraction-free design, because distraction-free design is the kind of thing that ensures that while someone's going 70 miles an hour down a motorway, they're not going to be distracted by a pop-up asking them to pull over right now and play a game. Even if you're driving out in the wilds, if you're distracting the driver, bad things happen. You do want to be responsible for this. There are so many things that can go wrong in a car that you want the driver's attention. Even Tesla, who without a doubt have the most advanced automated driving systems are not allowing drivers to let go of the steering wheel. They have a small system that detects when there's motion on the steering wheel, and occasionally the car will ask or will check that the steering wheel is moving to make tiny corrections. And if it detects your hands aren't on the wheel with a small motion, or even using one of the internal cameras, it will tell you need to put your hands back on the wheel. There are lots of not only legal issues around this, but just general, don't be a bad person and ask people to pull over to play your game while they're driving. So cars are complex. Automotive, long development times, huge specifications. It is not unusual for a 100,000-page specification for a single type of car. They go into massive depth. There are pretty much every component of the car, right down to the door handle, will have tolerances specified, use cases specified, and all of those kind of things. So the automotive industry is very geared towards specifying stuff in depth, and sometimes you'll find when you're developing automotive apps, if you get into bundling deals, and we are at the stage where you can get bundling deals with car manufacturers, you may find that their processes do not move as fast as you would for, say, a normal app development. That's not something that is saying anything about how you've approached them. That is about how they work. We have worked with manufacturers who spent 6 months exploring an idea only to can the idea. It happens in the automotive industry. You need to be prepared to take a bit of a slowdown in the speed of your development process. And I don't know about you guys, but I get a bit nervous when I don't hear back from someone who I might be working for a few weeks. In the automotive industry, that's not unusual. So when you're approaching automotive apps, when you're talking to automotive companies and all this kind of thing, and there are lots of opportunities out there, don't worry about it taking a lot longer than you're used to. There are a lot of terminology and a lot of systems in the automotive arena. This is not something I'm going to talk you through. This is not something you even need to be massively aware of, but this gives you an idea of how deep those specifications go and the kind of industry-specific knowledge that exists. AutoSAR is a system for how the controllers talk to each other, how the traction control knows whether the braking's engaged, and all of these kind of things. This is massively complex, very safety critical, but it's also sitting below the level where Android usually works. So you won't have to worry about it, but if people start talking about AutoSAR and things like that, there's even automotive Ethernet, because the standard Ethernet cables you have radio interference coming out of them. And those interference levels, when you're talking about 100 megabit and gigabit Ethernet cables that you might run around your home, that interference is too high for the safety standards in cars. So there is automotive Ethernet that is used, which has a lower amount of electrical interference across the car. So again, there's custom terminology, but a lot of it you don't need to be concerned with. You don't need to worry. Just know that there are going to be terms thrown up that you're going to go, I'm not even sure what that is. And there are a lot of people in the automotive industry who aren't sure what it is. There are things like ADAS, Advanced Driver Assistance Systems. That's a lovely term, but no one will tell you whether that's self-driving cars or whether it's lane assist or whether it's automatic braking, because the definitions are quite loose for the high-level technologies, but the specifications for implementation are really tight. So there are also some new players coming into the game who may change things. Xiaomi. We've all seen Xiaomi phones, probably. They are looking at producing cars. Foxconn. Now, Foxconn are a manufacturer that some people may have heard of in the room. They are Apple's biggest hardware partner. They've announced a car. That's Foxconn, not Apple. There are a lot of new players coming into the market, and this is why there are a lot of opportunities for automotive. This is the reason I'm here, is to try and get you guys a jump start on when you talk to these folk about what can be done, how you can help them, and if you want to, go and work for them. So Android in cars in the past has been an interesting situation. The thing on the right is a aftermarket modification where It's a 3D printed wrapper that you can take a section of the dashboard off, clip it in, clip a screen in, and you can run, originally it was Android 8. Not modified for automotive, nothing special about cars. It was pretty much a tablet in a 3D printed shell. It's interesting because that offers a lot of opportunities for running apps, but also it means that things like Pokemon Go that's screaming at you that you're going to be going past a Pokemon is going to be popping up while someone's driving down the road. Not an ideal situation, but it's there. And when you might think that Android 8 is old, there are still cars on the road that have Android 8 in them from the manufacturer. This long, long tail of a car existence where you're talking about 10, 20 years really does come through in automotive. And we'll see that come through in years to come where cars launching now will get 3 to 5 years probably of upgrades of Android versions, and then we'll stay with Android 17 for the next 10 to 15 years. There may be changes. People may start doing longer upgrades. I'm sure everyone in this world would love Android phones to get upgrades for longer than they currently do. But at the moment, you need to be thinking about how you're going to adapt your app for older versions of Android and not just focus on the latest cool functionality. So what do we have at the moment? We have 3 different things. We have assistant driving mode. That's when you put your phone in the car vent. It's useful, but it's not really automotive. It's just a special layout. We have Android Auto, which is projected mode. Now, this thing looks similar to the previous slide, but this is actually a specialized in-car system where your phone becomes the device that's running everything, and the car becomes just essentially a dumb screen. That, we think, is going to gain a lot of popularity, because instead of having to take your car apart, you just have to upgrade your phone, and suddenly you can do a lot of more interesting things. The final one is on Android Automotive OS. We think this is gaining popularity, and we think that this will continue to gain popularity in a lot of places where people want a car that does everything for them. They don't want to use Android Auto. They don't want to fight Bluetooth. They don't want to have a cable. They don't want to do all these things. They just want a car that will offer them the latest apps and the latest features, and they don't have to worry about how it connects. Now, Android Automotive OS, it's a little bit of a mislabel. It is not the OS that runs the car. Underneath Android Automotive OS, there is usually a real-time operating system that deals with how the sensors in the car interact with each other and generating a consistent view of the car at a point in time. So when you're dealing with Android Automotive OS, you're not going to have to worry about your app being laggy, causing the car not to brake in a collision. But the things you put on Android Automotive OS should still be focused on the car. So there are a lot of good training resources. If you're interested in Android Automotive, in the code and stuff like that, I'd refer you to Google's learning resources. They have a lot of good courses to go through. I'm not going to be able to take you through designing a complete app in 40 minutes. There are a lot of nuances about how you design apps. There are small differences between Android Auto and Android Automotive, particularly in things like how you display icons. And yesterday at the Wednesday on the Android Development Summit, Stav and Jay did a wonderful talk that took you through in 15 minutes a very high-level view of a code lab. If you want to see that, that is a great way to learn how to write a quick app. What I'm going to do is talk more about the surrounding technical concepts and the surrounding technical issues that you need to be aware of. So the projected mode is something that today is the most popular way that people encounter Android in cars. There are millions of cars on the road that support Android Auto, and it is likely to become, as I said earlier, a much more popular thing as people get older cars that are capable of doing Android Auto. If you have Android Automotive running in your car and it's running Android 17 and it's now a 5-year-old release, we believe people will start switching to Android Auto in that car. So we see this in a lot of the second-hand market. It's not going to be the massive thing that the high-end adopts, but it is going to be something that for a lot of people, and there are a lot of people who have cars who aren't going to be buying £50,000 EVs, we see this being the main thing that they will use. Easy upgrade of the hardware makes it a no-brainer. You don't have to go down to a Whole Foods or some aftermarket stereo dealership to get your car upgraded. With Android Auto, if you've got a recent phone, you've got a recent version of hardware that is going to be powering your in-car experience. So there are lots of different units, there are lots of different options. You can get aftermarket stuff, but then you move on to Android OS embedded. And this is where a lot of car manufacturers are going. We are now in a position that we were in with phones in 2008, 2010, when manufacturers are realizing that the old feature phones, or the old feature cars in the case of automotive, aren't giving a rich enough experience to meet what people need and what people want. We're talking to some big players. We're talking to Ford. We're talking to BMW, Volkswagen, Mercedes-Benz, Polestar, which is part of Volvo, which is part of Geely, who are a massive company who have brands all around the world. All of them are moving in this direction. So this is a market that it is expanding. And how Android Automotive OS differs from Android is in a very small way. There is a vehicle HAL, because there are some very specific challenges in cars, like charge levels and all these kind of things. And the vehicle HAL talks to the library which presents the car APIs to your app. That is not something that has any similarity to current Android standards. It is mostly a properties-based system. It's a lot of get, and if you have the right permissions set, there isn't an API that you have to learn each different method call to get every different type of data. It is a very property-based system. And the car apps are literal overrides. If you look into the Android open source builds, or you look into the source code, you go to source.android.com, you go to cs.android.com, what you'll see is the car launcher has a makefile that says, remove the normal launcher and put me in its place. And there are a small number of apps that do that. Settings, car launcher, not many other things. And that is it. The core of Android is still exactly the same as you're used to and you're using today. And that's how similar it is. You use Android Studio to develop for Android Automotive OS. You're not using specialist tools. The only thing that is slightly specialist is the emulator image. You're using the same emulator, but in the same way you can get an Android 11 and an Android 12 emulator image, you get an Android Automotive emulator, so you have access to this car launcher, you have access to the media player which is used to control what the user is listening to. So this is kind of where we at Snapp Automotive are approaching things from. We're Android developers. My background is Android firmware. This all sits on top of this real-time operating system I mentioned earlier. At the moment, there is a name coming back from the past that some of you may recognize. It is the name of BlackBerry. BlackBerry have a product called QNX, which is a real-time operating system. The movement of the market at the moment is that Android Automotive will run in a virtual machine on top of QNX. There are people who are using separate systems, separate system on a chip, but automotive manufacturers are very sensitive to costs. If you take someone like BMW, who are producing 500,000 cars a year, $5 represents $2.5 million of potential cost. So by going back to one system and having the virtualization layer that Android Automotive sits on top of, these car manufacturers are saving themselves potentially millions of dollars, tens of millions of dollars over the lifetime of a product. And it's something Google is supporting. Google have worked with Qualcomm and BlackBerry to work on a virtual I/O system that means that Android sitting on top of QNX's hypervisor is considered a first-class implementation. It's no longer a case of, well, someone's saving a bit of cost, they're using a virtual machine. This is a tier 1 implementation that we will want to support. So Google Automotive Services, or GAS, as non-Americans, we probably don't find the use of the word gas as funny as the Americans do, because to them that's petrol. We don't power our cars with gas unless you have a hydrogen car, and given that we've got less than 1,000 people in the room, there's probably less than one person who has a hydrogen-powered car. Google Automotive Services is equivalent of GMS. It is specialized for automotive stuff. It is giving you all the features that you would expect from GMS, so fine location provision and things like that. But it is not the only path. Some of the big automotive manufacturers have concerns about going with Google and going with gas, and so they go with gasless, which is there. Given the fact this is the UI that the Snapp product we've produced creates, calling it gasless, for Americans that would be worrying, but for us, it just means there's no Google on there. It's a perfectly valid way to implement Android in cars. Big German automotive manufacturers are considering it, as are a number of Chinese manufacturers, as are a number of Asian manufacturers where Google is less of a thing. Russian manufacturers are also looking at it. In America, Google is king. Chromebooks, large amounts of sales are made there. Not having Google in America is like, yeah, that's going to really hamper your product. In Europe, the auto manufacturers tend to own parts of navigation companies. So they have an interest in using their own navigation solutions rather than Google Maps. They also believe that they can implement their own solutions for things like app stores and all those kind of ideas that back in 2008, 2010, folks were thinking about for mobile. We tend to go to them and say, you can do it. If you can, have a chat with Amazon about how their app store has gone, because they've been at this own app store business in our own hardware for a while. Tell us how the conversation goes. And gas-powered, so Google Automotive System powered, is a popular thing. Many of these companies are conglomerates. Many of them sort of see each other doing things like GM and Ford tend to look at each other and go, you know what, we're going to do that because the other guys are doing it. They're also North American focused. Volvo have done it, Fiat have done it, so it's starting to trickle into Europe. Renault have had a very strong partnership with Qualcomm and Google, and the Renault Megane, which runs Android Automotive OS, I had to play with it over at the Munich Motor Show. It's a good implementation. It's better than some tablets I've used by an awful long stretch. So GAS, Google AAOS, is going to be a strong thing, but it is not going to be the only thing. So what does it look like? It's Google branded. There's no escaping it. If you're sitting in a Volvo, if you're sitting in a Hummer, they're going Google as well. You're going to know you're in a Google-powered environment. It's very restricted on what you can actually do with it. So there is some amount of theming that goes on, but you'll find that there's a surprising amount of similarity between cars. The Humvee has a very much more industrial design, the military kind of action man, superhero action film type style. Polestar have a more minimalist, stylish kind of thing, but if you look at the layout of the components, the screen space you're going to get, and how your apps are going to work, they're very similar. And there are things like charge levels in EVs. You're going to get access to those in the next level of Android Auto APIs. In Android Automotive, you get access to them as well. You may want to use apps to gain access to this stuff, and this is available on gas and gasless cars. A lot of the functions of the car are available on both. It is just things like navigation and small bits of functionality that Google have put in Google Automotive Services that you're not going to get access to. This is a Renault. It's a very nice car. I've got my fingers crossed it will come out at a very attractive price point and be available to a lot of people in a lot of years, because this is a great implementation. This is another cockpit design. Hopefully the thing that's coming across you right now is there's going to be a lot of design to cars, from screen sizes to orientations to the way that things are laid out. There's even a car in China that allows you to rotate the middle screen. So this is going to be the kind of things that folk are talking about for Android 12L, for the large screen stuff. That's going to be relevant to cars as well. You can start splitting the screen up. You have that space. It's another design. This one is the Humvee. action movie, military, industrial, whatever tag you want to put to it. It's very much a style on top of a very similar set of functionality. Here's more styling. There really is tons of it. So getting your app into cars, safety is the #1 thing. Now, there's a lot of legal questions about liability and all this kind of stuff. Those have yet to play out. But if you're producing an app which you wouldn't want people interacting with behind the wheel, then automotive shouldn't be your first thought. If you have to think about, would I be happy with the person who's driving me down the road having my app as a thing on their screen, then you really need to think deeply about that and ask yourself, am I designing something that could potentially cause problems? So at the moment, with Google's templates, you are very limited to what you can do. Navigation, media, and messaging. Now, Google's templates are very much focused on making sure that you don't do anything dangerous. If you give someone a templated system, they are not going to be able to design an app that is going to fill the full screen with distracting information. This is Spotify's app. Now, the amount of things on that screen that Spotify actually provide is limited to the cover art and the logo. So these templates really are restricting everyone. It's not a case of there are a couple of people who are getting away with fancy things. The only way around it at the moment is for car manufacturers to publish full-screen apps through their own Play Store account and download them. So there's a better route planner, which Polestar have done a deal with, the developer of, to get that into their cars, and that's a full-screen app. But there is no gas way of getting full-screen apps into people's cars. So doing apps for Android Auto and Android Auto OS, one of the things that is enforced is there is a stack of templates that you can use. So you have a primary task, the thing that someone's doing, navigating, whatever it may be, looking for a charging station. And then you can have a very small number of subsidiary screens off of that. And your apps should be very simplistic. They shouldn't be like a Swiss Army knife of utilitarian functionality. So what we're looking at is in-car apps having a market of 100 million cars. It's not a small opportunity. It is really worth getting into, and getting into it at the moment, you're in the early days. So they're also looking at whether you can integrate the person's experience into the car. At the moment, a lot of people have their apps on their car, they have their car environment. If you can start bringing those together, you're going to produce some very appealing apps that there are going to be motor manufacturers who probably want to have conversations with you about licensing deals. All of the manufacturers want the car to become an extension of your phone. They want to make it into an environment where you're not spending hours looking at settings, but you're just getting in the car and you're going. And the constraints, as I mentioned earlier, there are only a few templates. These are changing. We've had conversation with Google about expanding the list of templates and things like that. They're open to it. You'll see in Stav and Jay's talk, they're even saying, come and talk to us. If you can think of things that are genuinely useful in cars that cannot be done with the current templates, talk to Google. They want to know this stuff. So these are the various types. This is on Google's training material. These are the various types of templates and what you can get from them. I'm not going to go through each one. As I've said, Google have done a great job with their training material. Refer to that because this stuff does change over time. And there's limited customization as well. If you think you're going to develop an app and it's going to have all your own styling, that's not going to happen. You need to be willing to let go of some of your branding and leave it to the car manufacturer, to Google, whoever, to produce the style for your app that your app will fit into. You can use some of your own colors, you can do things like that, but it's a very limited amount of things that you can do. So yeah, you've got these constraints. You've got plain list template, you've got all the various templates. I'm going to skip through these. These are the things that the Berlin talk goes into in far more depth. If you're, as I said earlier, if you're interested in the design of it, the templating and all that kind of stuff, check out the DroidCon Berlin version of this talk. It will give you a lot more information, a lot more examples, and Pierre, who presents with Johanni, will go through one of the projects that we were involved in and how it evolved and how we ended up with a product that the customer, the large charging company were happy with, and we were happy with, but still managed to stay within the constraints of the current templating system. Car UI versus the phone UI, it should be obvious at this point, don't use small touch points. You want big text, you want things moving around. You're gonna want to make sure that the user can actually tap on stuff. So you can take that out on the road, you can tweak the manifest in small ways to make things car friendly. There are lots of little bits you can do. The app on the left is one of the apps that has been installed in a car and wasn't designed for it. That's a horrible experience you wouldn't want to put on people. So developing for OS, what can OEMs do? They can do quite a lot. They can customize it, they can put in vehicle house, they can put in house for their own things, all of this kind of stuff, which is a benefit when you're producing the vehicle. This is gasless OS. This is the product we produce. This is what we talk to manufacturers about using. It's a relatively simplistic system. That's Charge Cars, that's Lucid, all designed with Android AAOS, or Android from the start. Charge use a base platform from Arrival, which is a pretty solid system. So there's interaction patterns you need to consider. You need to make things simple and quick actions. You can't have drivers lingering their finger over things and hard and long pressing. You need to think about hands-on driving, using voice commands more. People talk to their cars. And minimal distractions, glanceable content, comfortable touch targets. All of these things are designed to keep the app simple so that it's not making the user do a lot when you're looking at the road, so you can switch across and go, okay, I know what I need to know, or I can touch it very easily. Simple navigation methods. Theming. It's going to be themed by the OEMs. You're going to have to live with that. Developing for iOS cars. This is my setup at home. You may notice on the right is a 2010 Mac Pro. That's my main build machine. That's what you can develop on. Modern machines will create a firmware build in about 2 hours. The Mac Pro does the same, the 2010 Mac Pro. It's a dual CPU, it's a big beast of a box. But we're now at the point where if you run Linux on high-end commodity desktops, you'll be able to do a firmware build in a couple of hours. If you do it on a laptop, you might be taking all day. But it's realistic to produce your own firmware on a machine at home. You can work remotely and do this stuff. This is a test setup from Qualcomm. Who would want to have one of these sitting at home instead of a phone? This is the kind of thing that they'll show off at shows, but it is not the kind of thing you need to develop for cars. This is what we use. 250 quid Samsung tablet, 20 quid coffee cup holder. I do not drive and use the tablet. My wife drives and I use the tablet to test things out. I would not advise anyone testing hardware while they are driving. Okay, let's be very clear on that. And old hardware is new. It's a case where you're going to have to consider the Intel Atom in Polestars as something which is still a relevant platform. Kia, you'll see through the steering wheel, that's the instrument cluster that you're not going to be able to get on. The screen to the right is where you've got to think of your apps being. You're not going to be overlaying the speedo or anything else like that. As I was saying, the vehicle APIs, there's properties. You can see from this screenshot how small it is. There are a lot of properties. The biggest key thing is learning what's there. So you'll also have to deal with permissions. You don't get free access to all the car properties. You need to deal with that. And when you're building, if any of you built Android from scratch, this is a familiar screen. This is the Android Automotive OS build. It's a normal Android build. When I was saying earlier about how close stock Android and phone Android is to Automotive OS, it goes right through to the build process. There is practically no difference. It's only in what's output and the launcher that change. You can develop the launcher in a repo. We do it. It's developed as an APK. It's not something that has a lot of special processes. You can develop it as part of the tree, and you can use some specialized tool, but you can also develop a lot of this stuff separately. Rear seat entertainment, It's a screen in the back of the car. No remote control, no motion sensors. You've got to do something to touch interaction. But it tends to be used by children, so you can do things that are more engaging. So what happens next? This is the crystal ball gazing part of the talk. Touch is going to become the thing. If you're developing apps for TVs, they can become relevant to rear seat entertainment. You just need to use touch instead of the remote control. And Mario, who's the Android developer advocate over at Amazon, has done a great job of taking the Amazon Fire TV developers from your app is on a 40-inch screen 6 feet away to your app is on a 10-inch screen 3 inches from someone's finger. And they're going to touch things. They're not going to use remote controls. There's going to be an ecosystem battle. The big European manufacturers, the Chinese manufacturers, the Russian manufacturers don't want to go Google. So there's going to be Amazon, there's going to be Huawei. Forcia and Harman are offering white-labeled solutions that people are going to brand. And there's going to be an ecosystem battle with assistants. You're going to be talking Alexa, we're going to be talking Google Assistant. Tesla, Apple cars, we may see those. It's another thing to think about. And there's a revolution in manufacturing. It's becoming more like PCs, where PCs are built together, bolted together, built up like a PC. So you may find that property sets change slightly between models. This is a lovely car. This is a charge car. There are 499 being built. It's built from the ground up, but it looks like an old car. So we're even seeing the kind of tech that you're going to be deploying to in new vehicles. And you got connected beyond the car. This is part of extending the experience. Do a better job than Polestar have. If you talk to people who've used Polestar's app, it's a horrible way of extending the car experience to the phone. And don't ask for in-app purchases in cars. Please don't. It annoys enough people in games. Cars, it's just going to stop people using it. Thank you very much. I am out of time, but I'm going to be hanging around if you've got questions for me. Grab me a little after this talk when the guys have grabbed their microphones and stuff back. Thank you very much, and hopefully this was useful to you.